Paul McWhorter has a series of lessons on the Raspberry Pi Pico W. The last lesson he offered as of this week was lesson 30. In lesson 30, he used the Pico W to log on to an internet website, download some data, and then manipulate that data in a mode that might be useful to a user. For a homework assignment regarding this lesson, he asked that we connect to a website, download some data from that site, and show how to use that data in a way that others might benefit from using that. The Pico has an onboard real-time clock. The problem is that the real-time clock always resets every time the Pico is turned on, so you don't always have the current time and date. In this video, I want to show how to go online, download the current date and time, and set up the real-time clock. In this video, I will show you how to download the real time from the internet, set up the real-time clock, and then display the current time and date on an LCD display. If we look at the code, the first 21 lines of code involve importing libraries, setting up things that we need for the liquid crystal display, the real-time clock, and to log on to the Wi-Fi. Following that, we have some functions. The first function is to see if we're already connected. If we are, it returns a true. If not, it returns a false. So following that, I have a connect function, and the first thing it does in this while true loop is to check to see if we're connected. And if we are connected, it will display what our local IP address is for the Pico and the status. And it'll also display on the LCD a Wi-Fi connected message. And it'll break out of that true loop. If it doesn't break out, if it's not connected, I'll print a statement that it's trying to connect, and then go out and do the connect. So it will stay in this loop until forever. If it never logs on, it'll just be displaying this message over and over again. If it finally logs on, it will break out of the true loop. Following that function is the function where we actually go out to the website and read data. The website is called worldtimeapi.org, and if you go to that website, it has information about all the things that can be downloaded from the website. So now again, I have a while true loop and a try function here, and on the try, if there's LCD connected, I display a message on the LCD that we're getting the date and time from the internet, and then I actually go out and connect to the Wi-Fi, delay a second, and then read the information that was downloaded into this variable called response. And if we didn't have an exception, well, that means that we were able to read it. So we set the read flag as true, and we print the current time information. That is this website that we're logging on to, and the status that we got. We also display a message on the LCD that we were able to get that information, and we break out of this try statement. If we had an error, I'll print a message that we had an error status, which is 2, and the response code. And I'll also print out a message that we had an error on the LCD display and break out of the try. Now, if we didn't break out of this try thing, we will continue down on to this if statement. If we were able to read, that is, if the read was true, I put the data that was downloaded into a variable called JSON, and I print out the JSON information. And if we dig down into the JSON information, we eventually come up with what's needed to set the real-time clock. And this is the order that we need for the real-time clock. We need the year, month, day a week as a number, the time in hours, the time in minutes, the time in seconds, and the last one is sub-seconds, and I make that default to a 0. And then we leave that function. Following that is I have another try statement that I do a scan of the I2C port to get the address of our liquid crystal display, and I print that address. If it fails, I'll print a message that there's no LCD display and set that to a false. Now let's go down to the point where we start displaying stuff. I set 2 values. One is the old seconds and one is the old day to values that are not valid. So the first time through, we will automatically say we've had a change. And then we actually go out and call the function to get the time and date from this website. And following that, I have an array of months set up as strings, as an array of strings. Then I have a while true loop. The first thing in the loop is to get the time from our real-time clock. I print the time that's received from the real-time clock, and at the end of that line, I do a return back to the beginning so that each time I read this, it just overwrites the previous one instead of a new line each time. So let's look to see what else we do. I look to see if we had a change in the day. If we do, then I build a date string of of what month it is, what day of the month it is, and the year. I pad that string with spaces in case it's shorter than what's up there previously. Then I go out and output that string to the upper left character of the LCD display. Then I look to see if there's a change in the time. That is, I look at the seconds that was returned from the real-time clock to see how it compares to the previous reading. If it's different, then we want to output a new line. So I build a string that includes the hours, minutes, and seconds, and I also pad that one in case the line is shorter than what was there previously, and I output that string to line 1, the leftmost character. That's the lower line. And then I delay for a second, and this goes over and over again. And you might want to do something that I'm not doing in the video. One thing I haven't done is to test to see if there's any drift in the real-time clock. If you find that you're having a problem with the time drifting, you may want to periodically go out and get a new time and date from the website and set up the real-time clock again. You might want to do that, I don't know, on a daily, weekly, or monthly basis, or even a yearly basis. So let's look to see what happens if we run the program. We run the program, okay. We're on our LCD display is at address 39. Our local address for the Pico is this 192.168.1.185. And then down here we have the data that's returned from the website. And if you drill down through that data, you can get the information that's needed to set up the real-time clock. And you'll notice on this bottom line, the real-time clock is updating every second. And you also look over at the display, and it's also updating. So now we have a way to update our real-time clock and manage to use that data to perhaps do some event at a particular time of day.